Are you overwhelmed by information? Do you want to do the best for your health, but there's so much conflicting opinion out there, it feels a bit like you're trying to navigate your way through a maze of noise? In this video, I'm going to break down the concept of evidence-based practice. I'm going to explain what it is and how health professionals use it to make decisions. So buckle up, we're going to get critical. Hi, I'm Ruth and this is Wise Women's Wellbeing, a place for women who want to be in great health so they can live their best life beyond the menopause. As a retired doctor turned health coach, I like to sprinkle a little bit of science onto my well-being so you can make informed choices. I combine my education and experience in medicine, psychology and coaching with my lived experience as an over 50s woman navigating this exciting phase of life. If this sounds in any way intriguing to you, then come join us. Please give my videos the thumbs up and subscribe so I can grow my channel. In this video, I want to create a strong foundation for future content by looking at what we call evidence-based practice. I'm going to firstly explain what it is and run through the different types of scientific study. I'm then going to explain why it's important, and finally, so keep watching, I'm going to give you some red flags for looking for bad science. So evidence-based practice is a systematic way of making health decisions based on available evidence, clinical expertise and patient preference. It's essentially how guidelines are set both at national and local level, and there's a process which is followed. Firstly, the evidence is evaluated to see how robust and how good it is, and based on that a recommendation is made for a treatment or intervention. So there has to be involvement of stakeholders. So typically that will be the people providing the treatment or intervention, for example, the NHS, and the people receiving it, so the public or patients. And then there's a whole load of factors which feed into that, including the feasibility and, yes, the cost. So if the evidence is good and everybody's on board, then the intervention is rolled out, but that's not where the process stops. So once it's rolled out, you've got to know that it's doing the thing you want it to do. So that's where data collection comes in, both in terms of asking people how it's going and something a bit more scientific, so collecting data for audit. And that's how we make ongoing tweaks and improvements. So this is the bit of the video where it's going to get a little bit more complicated, but I'm going to walk you through it step by step. So when it comes to assessing evidence, there's essentially a hierarchy of how strong, how good it is, so called the hierarchy of evidence, which basically looks like a pyramid. So here it is, and the higher you get up the pyramid, the stronger the evidence. So at the bottom we have opinion. This is the weakest as it's not really backed up by anything. So this is a huge category as it essentially includes books, social media, magazine articles and so on. And yes, that does include me talking on the internet. So books, a lot of you might say, but books have references in, and yes they do. So this is The Diet Myth by Tim Spector. And yeah, he's done a great job of citing his sources, and yeah, all of the references are at the back if you want to go away and read the source material. One of the problems with books though is that they get outdated quite quickly. So yeah, new science comes along, which is why this one's obviously been updated and says new and updated edition on it. The other problem with books is they're not peer reviewed. So they're reviewed by someone like me, but they're not reviewed by a consensus group of nutritional researchers. And that's where peer-reviewed journals come in and taking us on to like the next layers of the pyramid. So when it comes to journal articles, at the bottom we've got case studies. So these are essentially a one-off about an interesting case, a case that provides a learning opportunity or it's something rare. But the problem with these, again, we can't extrapolate them very far. They're kind of one up from opinion and essentially medical anecdote. It's kind of like me saying, for example, my grandma smoked 20 cigarettes a day all of her life and she lived to 95. So therefore cigarettes are completely safe and it's all fine. That is clearly rubbish. Well, on both counts actually. My grandma didn't smoke at all. I'm just using an example of why case studies are limited in what they can tell us. So next we've got animal and in vitro studies. So in vitro basically means not in the body, in a test tube or culture dish. I'm not going to obviously go into the ethics of animal experiments. It's not within the scope of this video. Suffice to say, rats are not people. And neither are cells in dishes. So again, it's really hard to take evidence from animal studies or cell studies and say the same is going to apply in a huge complex human rather than just one of their cells in a dish. The obvious example of this is the tragedy of thalidomide. That was tested in non-pregnant rats. The rats didn't die, so it was assumed it was safe, and obviously it very much wasn't. So moving up the pyramid, we're getting into the more complex stuff now, so we're going to need to get our sort of science geek on a bit. And we've got the observational studies. So these are case control and cohort studies. And yes, I'm going to tell you what the difference is in a minute. So these are observational, so looking at what happens in groups of people over time through observation. You're not intervening in any way, you're not giving them anything like a drug. So the criticism of observational studies is they will tell you if there's an association, they won't tell you if there's a cause. So example, let's take disease A and risk factor B. We can say that risk factor B is associated with disease A, but what we can't say is that risk factor B causes disease A, because we don't know. It could be the other way around. So having disease A makes you more likely to have risk factor B, or there could be something else. So if you've got risk factor B, you've also got risk factor C, and risk factor C causes disease A. So it looks like there's an association, but it's something else involved as well, another variable. So this is obviously one of the criticisms levelled at the observational studies. So case-controlled studies and cohort studies are basically two ways of looking at associations. And the difference is that case-controlled studies look back in time, look at the past from the point of the study. So that's called retrospective. And cohort studies at the start of the study then look into the future. They look at prospectively what is going to happen to those people. So they obviously tend to be very long studies. And I'm just going to use some diagrams to just explain what I mean. So this is how a case control study works. So this is the point at which we start the study. And then basically we're looking back into the past. So we're going to start whether people have disease A or not. So we have a group here and they have disease A, and we have a group here and they don't have disease A. And then we're going to look at whether they were exposed to risk factor B. So here they were exposed to B. And here they weren't exposed to B. So we take the people with disease A, were they exposed or not? And then we take the people without disease A, were they exposed or not? And then we compare these two groups. So here's a slightly neater version if you want to screenshot it. So this is a cohort study. So in this, we'll start the study down here. And then basically we're looking forward into the future. So this time we're going to start with the risk factor B. So basically, have they been exposed to B or have they not? And then we're going to go forward into the future and we're going to say, is disease A present or not? So yes or no. So then we're looking at the people who are exposed to the thing. Do they go on and develop the disease A or not? Then if they're not exposed to thing B, do they go on and develop the disease or not? And then we compare. And my pen's running out. And there again, a slightly neater version, although I've smudged it, sorry. Now at the top of the pyramid, we have the randomised controlled trials. These are the kind of more sciencey experiments where you're giving people things and seeing what happens. So you have a group of subjects, of participants, and one group gets something, a intervention of some kind, a drug, a diet, and the other group, the control group, don't. And then you measure a predetermined outcome at the end and look at differences between the groups. So again, I'm just going to explain that in diagram form. So now I'm going to try and explain the randomised control trial. So this is your gold standard trial. And what's really important in it is the concept of being double blind. So that means both the researchers and the subjects are blind to what's going on. So you start off with a group of subjects and then you do something called randomisation. And what you want to do is you want to put them into two groups, one who receive the intervention and one who receive the control. So splitting the subjects into these two groups, this is called the randomisation process. And if it's a good study, that should be done by somebody who isn't one of the researchers. It should be somebody external. So the researchers don't know who's gone into each group, and obviously the subjects don't know who's gone into each group too. So the intervention group are going to get the thing. So, they're going to get a tablet, a capsule, let's say. They get the drug. The control group, they're going to get a placebo, basically. It's going to look the same, but it's not going to have the drug in it. So the subjects don't know which one they're getting and the researchers don't know which one they're getting. And then obviously you let some time pass and then you basically say, have they got the outcome or not? What did it do? And then you compare these groups. And at this point here, once you've collected your data, that's when the researchers are essentially unblinded. So obviously then they can retrospectively go and do their statistics. But this whole process, neither the researcher nor the subject should know who's in which arm. So the problem with everything we've looked at up till now is it's singular rather than plural. So we've just looked at evidence from one study. What would be really good is if we could look at the totality of evidence, because that will give us a lot more information. So one way of doing this scientifically is by something called a systematic review. So here you will formulate a research question that you want answered. You will then go out to the scientific literature and collect studies in a very systematic and quite time-consuming way that will answer your question. I'm not going to go into the process because it's quite drawn out, but suffice to say you get a group of studies at the end and you then review them for the quality to make sure they're good studies and they're not biased in any way. And then you basically draw your conclusions from their results. And if you want to go one step further, you can pool the data statistically, and that's called a meta-analysis. So one final point on the hierarchy. Whilst RCTs are kind of the top of the pyramid, it doesn't mean everything below it is a load of old rubbish. Observational studies and the information they provide is incredibly important. And going back to smoking, it's how we picked up that there was an association with lung cancer. Most people watching this will probably remember the MMR vaccine autism controversy. Andrew Wakefield, a British doctor, and co-authors published a study in the Lancet, so a very prestigious journal. And they said that they had found a possible association between having the combined MMR vaccine and developing autism and a form of colitis, which is an inflammation of the large bowel, the colon. So although this association was later refuted by an expert panel, it got a lot of traction in the UK press in the early 2000s. And it led to, understandably, a lot of parental fear and kids not getting the combined MMR vaccine and several outbreaks of measles. So in 2004, there was an investigation by John Deere, a Sunday Times journalist, and looking at that original paper, and basically he alleged that there was undisclosed conflicts of interest and bias in terms of data selection. And in 2010, following a fitness to practice tribunal by the General Medical Council, so the GMC, the regulatory body for doctors in the UK, Andrew Wakefield was struck off the medical register for professional misconduct. Now, he has said that he feels he was treated unfairly by the medical and scientific establishment and has gone to live in America, where he's a prominent anti-vaccine campaigner. So evidence also matters at an individual level, because when we're informed and we have better health literacy, it means we're able to make better decisions about our own health. And that's particularly important if, like me, you have some form of chronic illness. But it's also really important to remember that science isn't absolute and science can change, and people disagree. That happens all the time. Just look at nutrition. People, the experts out there, can't even agree on how best to eat. And science and opinion also change with time. If we look at menopause hormone therapy or hormone replacement therapy, HRT, how that's been prescribed and how much it's been prescribed is altered over time as different scientific studies are published. And that's why expert societies and groups exist. So in the case of menopause, the British Menopause Society, and they will review evidence as it comes along and publish guidance for health professionals wanting to make treatment decisions. So in terms of looking out for bad science, there's a couple of things you can do with the study. The first one, on a very basic level, did it answer the question that it set out to answer? A few other things to look out for was the sample size small, so only done on a small number of people, which makes it statistically less valid. Was there a control group in experiments, and were there any conflicts of interest? With that last one, there are things that can be done to manage conflicts of interest within research, in that research funding, yes, does come from industry sometimes, and there's ways of mitigating it, but a conflict should also always be declared. In terms of the reporting of science by the media and social media, here's a few red flags to look out for. Firstly, making conclusions about humans based on animal studies. Number 2, not citing your source. Obviously, if you're going to give information, it's good practice to back it up with the source material. Thirdly, cherry picking data to back up your claim, which is so-called confirmation bias. So, telling you what you want it to say, rather than considering the totality of evidence. Number 4, sensationalizing based on how you interpret results. So absolute versus relative. So for example, an absolute increase from 0.5 to 1 is kind of small, but if you flip that, you could say, well, there's a 50% relative increase, which sounds a lot more dramatic. Number 5, again, conflicts of interest. Is that influencer selling a fibre supplement? In which case, it might be in their best interest to say fruit is bad for you because it contains sugar. Spoiler, fruit is not bad for you. So we've geeked out, we've run through the hierarchy of evidence, and I hope what I've given you is a little bit of a primer that you can come back to and make your own decisions about whether you think something's valid or not when next time you see a science claim on the internet. Great if you could get involved in the comments. Do you like looking at the evidence yourself, or are you just happy to listen to the experts and just want me to shut up? It's up to you. Let me know. Let's have a conversation. So until next Friday, when I post something new, live well.